Today we're going to talk about geometric sequence and series. And before we do that, we're going to first review what recursive means. We talked about recursive on the first day. And basically, recursive means successive terms, the terms following the first ones. They can be found from the previous terms. An example of a recursive series is a sequence is the Fibonacci sequence, where you find the next term from the sum of the previous two. So if we're given a sub 1, then by a sequence being recursive, that means a sub 2 is found using a sub 1. So in this case, a sub 2 could be a sub 1 times some value r. And then, to be recursive again, a sub 3 is going to be a sub 2 times that value r. So a sub 2 times r. So when you're dealing with recursive, you always have an n minus 1 value in there, or an n minus 2, or an n minus something, where we are referring back to a previous term. So this is what recursive looks like. Now I can take this and I can write a sub 3 in terms of a sub 1, because I can replace a sub 2 with this guy here. So a sub 3 can also be represented by a sub 2 is a sub 1 times r, which means a sub 3, I'm having a little trouble with my stylus today, is equal to a sub 1 times r squared. And if I were to keep doing that, I could come up with a value for a sub n, and a sub n is going to be a sub 1 times r to the n minus 1. So that's where we get into a geometric sequence. So we're going to define a geometric sequence. And here's the definition. A geometric sequence is one in which each term after the first term is going to be a sub 1, each term after that is a product of the preceding term and a common ratio r, such that, here's my sequence. A sub 1 is the first term. The next term is a sub 1 times r. R is the common ratio. The next term is a sub 1 times r squared. And it keeps continuing until you get to the nth term. So this is the nth term. If I can write this. Okay, so we can represent the formula to find any numbered term like this. A sub n, the nth term, is equal to a sub 1 times r to the n minus first. R is called the common ratio. Instead of the common difference, it's the common ratio. And you find the common ratio, that's supposed to be an n, by taking a term and dividing it by the previous term. So it would always be a sub 2 divided by a sub 1, or a sub 3 divided by a sub 2. And that's how you find the common ratio. So let's do an example. Find the next three terms in this geometric sequence, 18, 54, 162. The first thing you do is find the common ratio. So r is going to be, I take any two successive terms. I can take 54, and I divide it by the preceding term, 18. 54 divided by 18 is 3. Now I can find the next three terms recursively. I don't have to use the formula if I'm finding just the next three terms. So a sub 4 is going to be 162 times 3. And that gives you 486. And you can keep doing that. So your next three terms are 486, 1458. I'm really having trouble with this thing today. And 4374. But let's say I wanted to find a term larger than that. That's when I would go to the formula. A sub n is equal to a sub 1 times r to the n minus 1. So if I wanted to find the 50th term, it would be 18. I'll set it up. I won't calculate it all out. But if I wanted to find a sub 50, if I can write here, a sub 50 would be the first term, a sub 1, times the common ratio, 3, raised to the n minus first power, raised to the 49th power. That's how you would find something as big as a sub 50. You wouldn't keep doing this recursively. That's not very efficient. That's where you would use the formula. So if I wanted to find the 12th term of this sequence, 1/1/2 times 1/4, well, I got to find the common ratio first. If you look at this, if I start with 1/2 and divide it by 1, I'm going to get 1/2. And if you just think of it this way, 1 times 1/2 is 1/2. 1/2 times another half is 1/4. So my common ratio is 1/2. Now, if I want to find the 12th, I can't even say that, 12th term, a sub 12, that's equal to, the first term is 1, that makes it easy. My common ratio is 1/2, and then I'm raising it to the 11th power. So it's 1/2 raised to the 11th power. You get some goofy decimal, or in fraction form, the exact answer is 1 over 2048. That's what you would get if you multiply, if you start with 1 and keep multiplying by 1/2 12 times. That's your answer. So we can also determine if the sequences are geometric or not. And you do that by making sure each consecutive successive term has the same common ratio in between. So if you look at 3 and go into 3/2, if I took 3/2 and divided by 3, I would get a common ratio of 1/2. 3/2 times another 1/2 gives you 3/4. 3/4 times 1/2 is 3/8. So everything here is the same. They all have the same common ratio. So it is geometric, and the common ratio is 1/2. Now, if you look at the second one, we have a pattern, but the common ratio would not be the same. If I divide 1/3 by 1/2, I would actually get 2/3. If I divide 1/4 by 1/3, I would get 4/3. They're not the same. So that does not have a geometric relationship. There is a pattern. We could set up that pattern using sigma notation once we get there, once we start doing the sums, but it's not a geometric pattern. Next, we're going to look at an application problem. A car is purchased for $21,000. It depreciates 20% of its value every year. And that's kind of standard. If you buy a brand new car, as soon as you drive it off the lot, you can't sell it for what you bought it for because it's already depreciated. So when you see depreciation, that's where you're going to subtract. The value is decreasing. Okay? Now we have to be careful with the way this is worded, and I always kind of lay it out to make sure I'm doing the right thing. I want to know, what is the car worth at the end of year 5? I bought it at the beginning of year 1. So, at the beginning of year 1, A sub 1, it was $20,000, which means at the end of year 1, that's my second term. End of year 2, that's my third term. Okay, that's supposed to be a 3. And then this is A sub 4, and this is A sub 5. So I'm really looking for A sub 6. If I buy it at the beginning of one year and I want the value at the end of another year, I'm trying to find A sub 6. So if we use our formula, A sub 6 is equal to the first term times the common ratio to the n minus first power. Well, A sub 1 is 21,000. My common ratio, you have to be careful. It is not 0.2. Because we are always using a product, and if I'm decreasing by 20%, that's equivalent to multiplying the whole number by 80%. It's 1 minus 0.2. So my common ratio, when you're decreasing, you have to subtract that percentage from 1. The common ratio is 0.8. And then n is actually 6. So A sub 6 is equal to 21,000, get this thing all right, times 0.8, and that's raised to the 5th power, 6 minus 1. You put all that in, and you end up with $6,881.28. That's a huge depreciation. I'm not sure if cars depreciate that much, but That's going to be the value of the car at the end of year 5. So now we're going to talk about a geometric series. Just like an arithmetic series, a geometric series is the indicated sum of a geometric sequence. So you take all those terms and you add them up. We have a formula for the geometric series. You do have to memorize this. The sum of so many terms, if it's geometric, is the first term, a sub 1, times 1 minus r to the n, it's not n minus 1 anymore, divided by 1 minus r. Please be careful. You cannot reduce these things. R to the n is much different than just r. These are terms. These are not factors, so you have to multiply everything out. So take a minute. Here's my example. Find the sum of the first 6 terms of this series. Take a minute before I tell you, and you figure out what a sub 1 is going to be, what the common ratio is going to be, and what n is going to be. That's all you need to know to use that formula. Once you have those things, a sub 1 is 2. The common ratio, now please be careful, this is 2 minus 6 plus 18 minus 54. So when you see subtraction, it's the same as 2 plus negative 6 plus 18 plus negative 54. So the sign's going to change. So to find the common ratio, it's the same process. The common ratio is going to be negative 6 divided by 2. So the common ratio is negative 3. And then n, when I want to find the first 6 terms, n is 6. Substituting all that in, you're finding s sub 6, and you get a sub 1 is 2 times 1 minus negative 3 raised to the 6th power, and then all over 1 minus a negative 3. If you raise negative 3 to the 6th power, you're going to end up with a positive term that you are subtracting. This ends up being 729. So it's 1 minus 729, all times 2, divided by positive 4. When you process all that, you get negative 364. So even though your values are increasing, every other term is negative. So you're adding and you're subtracting, then adding, then subtracting, then adding. And at that particular point, when n is 6, your sum is negative 364. So now you try the same thing and find the sum of the first 5 terms of that series. 5/3 plus 5 plus 15 plus ... You need to find the common ratio. You need to figure out what a sub 1 is. That should be pretty obvious. And n is going to be 5. So I'm going to let you figure that one out, and then we will check it in class. Finally, we can also do this without giving you a sequence. I can just give you the values. It's actually kind of easier this way. Find the sum of the geometric sequence. If a sub 1 is 3, common ratio is 3, and n is 5. This is a direct substitute it in and crank out an answer kind of problem. S sub 5, if my stylus will write, is equal to a sub 1 is 3, and then it's 1 minus 3 to the 5th. Because remember, in the sum, it's n. It's r to the n, not r to the n minus 1. Okay, that is supposed to be a 5. That's terrible. All over 1 minus 3. And then you just process that in your calculator. That ends up being 363. So to close this out, we're going to work more problems in class, but to close out this little lesson, you have to think about this. This is the classic math problem here. If I gave you a choice, or someone was given a choice between either I'll pay you $1 million right now, or I'll pay you a penny today, and then tomorrow I'll pay you 2 pennies, and the next day I'll pay you 4 pennies, and every day it's going to double for 30 days. Which one is the better deal? Well, obviously, the penny is going to end up being the better deal because that's the way these things go. But I want you to think about why, and can you come up with how much money you actually would make if you got a penny on the first day, doubling every day for 30 days. And we will talk about all of this in class.